Okay, we're back. So now I'm going to go over the second two tabs in this LPA code, which are basically going to gather the information about for this free variance fixed covariance model that we decided was the best fitting model specifically for 3 profiles because that is the lowest BIC. And what's cool about this code is that it makes another function, or it should make another function. But it isn't. Probably because I didn't include everything. And I broke it. Fuck. Okay, we're back, and we're going to make a couple more functions. The LPA2 tab that I have here. Well, between these two. But basically what we're going to do is we're going to explore the freed variance fixed covariance model, because that's the green line, and specifically for 3 profiles, because that's what we decided would be best fitting, because it had the lowest BIC value. I'm going to go through most of the lines in this LPA2 tab, and then I'm just going to run all of it because I've even had some trouble behind the scenes here for this video of running not the right amount of code on this tab and screwing up creating the function and kind of just screwing up how R is operating at all once I did that. So take note of that when you're creating a function. Make sure that you're running all of the lines that are needed to create that function. But anyway, the goal of this tab is basically to create this new function called create profiles mclust. And with this function, it's kind of cool because this is going to create a function that we can continue to use, that we could use for any data set. So basically the structure we want to use is this one here. It's freed variance fixed covariance. But that's just one of the four options that we decided to use in the first tab. So you can create this code and you can take any data set and it'll tell you which option is best for you. We're not just exploring, or it'll figure out which one is best and explore the one that is best. It's not just exploring that green line, that free covariance, fixed covariance. Although that is the only one that we're going to look at for this particular data set, you can use this code on any data set and it will pick whichever one is best, which is kind of cool. Anyway, that was a long way to say all of that, but that's what all of this up to here is doing. And then this is just taking that information from that function and putting it into a variable so that it can also plot a summary. So the function actually does give us some descriptives about the formula that we've chosen. Yeah. And that's about it. This is some jargon that I honestly don't really understand, but it's part of making the function. So I'm going to run the function and hope that it works. It did. Cool. We now have a create profiles function. So we're going to run our data. We're going to put that into this int3 variable, and remember that this function, when we specify which we're going to specify we want freed and fixed, but again, this can accommodate for a bunch of them. And the only real thing that we're entering here is the number of profiles we want to look at, which is again 3. It's kind of weird when you're working with functions that you've created because, yeah, we're putting in freed and fixed, but we also included every single option, so we know exactly what's behind the hood there. Kind of cool, but anyway, let's run this. And again, because summary, we included a summary part of our function, we're going to get some information here. So it's telling us the diagonal varying volume and shape. That's what that VBI means, whatever. With 3 components. got the log likelihood, the number of participants, degrees of freedom, BSC value, which we already kind of knew, and the ICL, which is another indicator value, but we're not super interested in it. And then it tells us how many people are in each cluster. So it looks like about half of our people, a little more than half, are in cluster 1. Fourth or so are in cluster 2, and another fourth are a little bit lower than a fourth are in cluster 3. So now that we have that information, we can actually look at how the people responded using the LPA3 tab. So yeah, this is just going to separate those clusters that we just made and just look at their responses based on which cluster they're in. So we're just separating our variables from our data. So this right, yeah. By cluster and looking at how people responded. So let's go ahead and do that, and it'll plot that over here. Boom. So we've got profile 1, profile 2, and profile 3. And I think the differences are pretty apparent here. You can see for one that profile 2, and yeah, we have z-scores here. I guess I could have elaborated a little bit more on that. Part of this is, well, this is actually just for that label there, but these are standardized scores. So basically what we're looking at is how each profile responded to each variable in comparison to the mean of the population. So we can see that profile 1 for every single variable that we clustered on scored above the mean. And profile 2 for every single variable scored below the mean. Profile 3 notably hated the cost. So it's kind of like one way that this could be interpreted is that these are the people who really care about cost. These are the people who really don't like much of anything, or really unhappy with the cost, I guess. Really don't like much anything, particularly the atmosphere people, which is kind of interesting because the way atmosphere was kind of is going into more information than I provided earlier, but atmosphere was kind of this overall feel of the campus kind of variable. So that's interesting that we see people who really score below the mean on the atmosphere. Maybe that's some kind of negative halo effect. Not that we can imply that from this data specifically, but that's just an idea. And then these are the people who are pretty happy with the cost and kind of somewhere. And again, I'm talking in kind of, I'm not meaning to imply any causation here because LPA does not imply any type of, like, you can't say for sure that because people didn't like the atmosphere, that's why they didn't respond this way. But it's a way to look at how people are responding, and again, take a whole population and look at groups that are more homogeneous with each other. So like we can say that this profile 2, these people who are responding low, they do seem to exist as a group of people. And so that's what LPA is useful for, kind of looking at these patterns of people and understanding your population in a way that you couldn't do just from the population data. So that just about wraps it up, and I hope you learned something about latent profile analysis.